Okay, Allie, I'm going to hopefully make you a quick video that'll probably turn into a little bit longer than a quick video. But I wanted to show you my collection of RC vehicles that I have upgraded or DIY'd with a microcontroller called Arduino. Now the Arduino are little Atmega 328 processors, right, that you have to code. So you have to write simple sketches, what they call sketches, and we use those in, like I said, RC cars, trucks, tanks, robots with cameras, goggles, and our own controls instead of using the typical controls. Now I also make quadcopters, all different kinds and variations for different applications. This one is for racing. It's very sleek. There's not a lot of stuff on it. This is the flight controller. This is the receiver. Then the battery goes in here. This one is for aerial photography. So this is a GPS. This is the flight controller. This is what's called the OSD, the on-screen display. This gives me altitude, speed, heading, where I'm at, longitude and latitude. And then that transmitter right here transmits all that information back to a PC so that I have Google Earth running and I can see where this quadcopter is in real time over the terrain on Google Earth. And then back here, this white antenna is the video transmitter, so I can wear goggles for the camera that's up front right here, okay? So this one is for aerial photography and sport flying. This one's for racing. And this one over here is for terrain mapping. We're not done with this one yet, but we're going to put a what's called LiDAR, a laser rangefinder, a couple of them on it. And this is your GPS module here. And this is your APM 2.8 and your receiver and that kind of stuff. Like I said, I'm going to try and make this video as short as possible, but it's probably going to take just a couple of minutes. Okay. So now over here is the Arduino modules. Okay, there's several different kinds. The kind that we primarily use is called the Mini. Okay, and this one we use because it's small and it's compact, obviously. This one is the Uno, and this one is the Mega. Okay, they all have an Atmega 328 chip integrated in them. Okay, this chip is 32 megahertz, this is 16, and this is 16. Okay, these two boards are primarily the same. The only difference is size. This one processes much faster and has many more I/O ports. Okay, so if you want to build a big robot or something large with a lot of functions, you'll want to use this if you have room. Now, when you get these Arduinos, they come in a bag like this, and this is what you get. You get the board, and then you get the headers. Okay, now these headers have to be soldered on, and that's primarily, I believe, why you don't see them in schools, because, well, frankly, teachers, professors don't know how to solder that well, and they don't want you guys getting hurt soldering. But I'm here to tell you, once you're shown how to solder properly, it's a very simple process and anybody can do it. It just takes a little practice. All right. So everything that you see here, all of these boards, I have soldered all of these. Okay. All of these pins have to be soldered on. So it's a little time consuming, but it keeps the boards very inexpensive. This board right here, I can get from Sichuan, China, for about $3 each. Okay, so this board will allow me to use my own radio setup, my own code. All right, this is a transmitting radio through the Nano or the Mini, right? And then that allows me to make my own controls, okay? So I'm not restricted to using off-the-shelf remote control controls on my RC equipment or my robots. All right, so this would be your typical RC transmitter receiver. If you use the Arduino stuff, you don't have to use that. This is what some of the code looks like. Okay, it's not super entailed, but there's a lot to factor in. Okay, now this is just for a 4-channel input, 4-channel RC input. Okay, I'm going to put you on the stand here. I'm going to plug this in. We're going to plug the transmitter in. We're going to open this up so you can see what's inside. Inside is another board with another Nano, just like this board. And these guys are going to be talking to one another. It's going to transmit out here, and it's going to be received here. Over on this side, I don't know if you can see it very well, are what's called electronic speed controllers, which are going to control the tracks, okay, through this function here. Obviously, this is the battery. I haven't secured it because we're just doing a quick video. And then these wires here, this is power, and this controls pitch and roll, or pitch and yaw, on the camera that I have on top, okay? And this is just a Tupperware box that I got, and I mounted it on a tracked frame. Okay, so this frame, right? So I built this little frame, put these motors on there, the tracks, the geared wheels, so on and so forth. I'm going to turn this on. All right, so I'm going to turn the headset on. And now we have video through the headset, through the camera. I can move the camera right here, left and right, up and down. And I can also operate the tracks, forwards, backwards, independently, just like a tank or a regular robot. So both forward, both reverse, or left and right. So you want one track to go forward, one track to go backwards to change your direction. All right, so forward, backwards, left and right. Okay. Now all of this is capable, or we're able to do all of this because of these little Arduino chips. And once you learn how to code these, what you have here on the left side of the board is your input. Your potentiometer input goes to each one of these pins. And then your output on each one of these boards is your servo motors. All right. So you can control, on this board particularly, you control 7 functions. Okay. So I can do 3 sets of tracks and 1 camera, or, just a multitude of things. I could, run the tracks and have an articulating arm, or a gripping hand, or, whatever you want to do with your robot, that all can be done with these. Now, the other thing with us having done our own code and build our own radios is I can have 3 or 4 or up to 10 of these on each unit. That means I can do 6 to 8 functions times 10. So I could literally have 70 to 80 different movements all on one system, not interfering with each other. If you go to the hobby store, Graves Hobby or something like that, and you just get a regular JR or Futaba, radio receiver setup, you can't do that. They're limited to usually 6 to 10 functions, and you can't cross migrate them with different receivers, all on the same chassis. So this is a really nice way of doing all of this. Building your own robots and building your own machinery. And that goes along with, flying what's called fixed wing airplanes, RC airplanes, the helicopters, the quadcopters, the drones. Everything can be done with this. These radios that we build are good for about a mile. Okay, they're not 10-mile radios, but, it's a mile line of sight is what they call it. So, that's very far to be flying or driving your piece of equipment. So I'm gonna take you back off the stand here, and I'm gonna show you in the goggles, because I'm not sure that you really got a good view of that. What we're actually seeing. And I'm gonna turn the camera left and right, and up and down. Right, so you can drive your robot with your goggles on, and be very sneaky. You can roll around the classroom or the neighborhood without having to be near your robot at all, and you can see where you're going and what you're doing. But anyways, I hope you're interested in all this, and I hope I didn't make it too long, and I hope it made sense. If you have any questions at all, you can always call me.